Thank you for the invitation to speak here. My name is Dharhas Pothina. I'm the CTO at Quansight. Quansight is a company that has a mission to support the Python open source ecosystem. So we actually hire a lot of the maintainers and contributors to a lot of the tools you guys use, like Jupyter and NumPy and pandas, and etc. Today, I'm going to talk about Jupyter and getting Jupyter installed on Azure. And first of all, why would you even want to do that? Before that, I'm going to kind of give a slight detour. So I've been in Python open source since about 2008, and I had to use Python before the cloud existed. And, I've been in research for a long time and then in the industry for about 6 years, and I love building tools that let people get work done. And today's talk is basically about that. How do you get stuff to the point where people can get stuff done? And yeah, so you want to use Jupyter. We've talked about Jupyter. Jupyter's basically the primary IDE for research and data science and AI. If you want to do real coding, switch to VS Code. But when you're kind of experimenting, you want to use Jupyter. There's actually lots of great ways to use Jupyter in the cloud. In Azure, I did a quick Google. You've got Codespaces, which you just heard a lot about of. You've got, Azure Data Studio, ML Studio. There's, lots of SaaS vendors like Saturn Cloud, Data Layer, Coiled, Databricks, Domino Data Lab. These all give you sort of one-click Jupyter notebook access in the cloud. Or you can install everything yourself. And today we're going to talk about the last one, roll your own. Let's install Jupyter, and specifically Jupyter Hub. And let's talk a little bit about that. Why would an organization want to roll their own Jupyter platform? These are some of the things we've heard. Quansight's a consulting company, so we go to a lot of places, and sometimes they don't want vendor lock-in. Sometimes the various platforms out there were built by, different organizations, and they don't align well with what the organization needs. They want to integrate it with other tools inside, or there's security or privacy concerns, and a lot of times it's also cost. Some of these platforms are pretty expensive, above your basic cloud costs. If you want to roll your own, we're going to go into some of the issues with that. Why did we, Quansight, start building the tools we've built? We went into clients who needed us to solve hard problems in machine learning or build new algorithms or analyze their data. And every time we went in, they didn't have a good way to handle Python, or they didn't have scalable compute. They couldn't do really big data sets. They're like, oh, here's all the data. We don't have a place for you to do any analytics. And this was like 3-4 years ago, and some of the cloud tools weren't as mature as they were today. So essentially, we needed Jupyter and scalable tools like Dask and Ray in the cloud, and we didn't have them. So let's do this. Jupyter Hub is a really good open source framework that lets you deploy a collaborative Jupyter environment actually on many platforms. It can be installed on an HPC system or on Kubernetes. It's designed to be very flexible and installed in many locations. And it's got instructions on how to install it on Azure. And it's really good. It's like quite a lot of information. It kind of assumes you know about Kubernetes and how to set up all your bits. But it's excellent. If you're a good DevOps person, you should be able to go in there and work your way through the instructions. But once you install it, then you're like, oh, we actually need to manage our Python environments, like you were talking about previously in Codespaces. How do you manage all your things? People want better collaboration tools. They want monitoring and login, single sign-on, access controls, MLOps tooling, workflow tooling, and suddenly you're not just deploying Jupyter Hub, you're deploying a whole set of tools. And you're making choices. Should I use MLflow or should I use something else? Should I use Argo or should I use Prefect? You get into this paralysis of, okay, which ones do I deploy and how do I integrate everything together and how do I make everything work together? This is the high-level dependencies of PyTorch, okay? And this is how many other libraries PyTorch depends on. This is actually not going all the way to the bottom. And this is just one library in the machine learning AI stack. Most organizational IT departments are not equipped to handle rapidly changing Python environments. The solution, which most organizations come with, is like, let's use containers. And that's not the full solution, because it ignores a whole bunch of stuff and it causes roadblocks in the organization. What we've seen is most platforms that are container-based, the containers don't change often. They assume that the containers are going to be fairly static. But most of the researchers and data scientists and engineers actually trying to solve problems in organizations, they update their Python environments often multiple times a day. And that process of an end user data scientist who needs stuff deployed and getting it into the platform has a lot of friction. In some organizations, it's 6 months, or more to get the latest version of pandas, the latest version of PyTorch. One large bank, which I will not name, it took them a year to change the pandas version in their container. And so we started hitting these issues as well. And so you start thinking about deploying this. You're no longer deploying Jupyter or Jupyter Hub. You're deploying a full data science platform, and it is overwhelming. Smaller organizations just throw their hands up and say this is way too complicated. Larger organizations, their IT departments are typically more used to deploying Oracle, deploying the stable, unchanging thing. And they sort of get overwhelmed by all the different pieces that have to kind of go together. So I came from government research labs where we had access to big HPC systems, and I could use a lot of compute. When I moved to the industry, I got really annoyed about how difficult it was to deploy everything I needed in the cloud. The inspiration for some of the work I'm talking about today is something that was done at the beginning of AWS, which was Star Cluster, and it was developed at MIT. And basically, you added some environment variables, credentials, and you said Star Cluster, start my cluster. And it would deal with setting, launching an EC2 instance and all that, and it would drop you into a Linux desktop with all your tools installed. And you didn't need to know how to use the cloud, but you could take advantage of it. That's sort of the inspiration of what we started building. We started building an open source platform called Nabari. And the way to think of Nabari is it is an opinionated distribution of Jupyter Hub. It takes all the pieces you need to have a data science platform. We've made choices for you. We made, okay, this is a pretty good, MLflow is really good. Let's just use MLflow. So it's got a bunch of opinions baked into it, but it's also just a reference architecture, and it's plugin based. So you can kind of, you use whatever pieces you want, but if you don't have any opinions, we'll give you something out the box that works pretty good. It can be deployed on Azure in about 30 minutes. I thought about doing a live thing, but it was a bit too risky, so I'm not going to do that. It's infrastructure as code, and it's we test it on Azure weekly. So we have automated CI that tests deployments on Azure weekly, because things change in the cloud, and stuff that worked a while back may not necessarily work because changes in Kubernetes versions and all that kind of stuff. So that's why the testing part is very important. It's all built out of open source components and frameworks, and basically you could build this yourself from root principles, but it would take you a while to get all the integrations working. Who uses it? We have a lot of smaller organizations who don't really have cloud or Kubernetes knowledge. They can install it and use it and maintain it without a problem. And we also have the enterprise folks who are, have a large Kubernetes team and, know how to use Azure all the way, but they're not familiar with the data science tools and the Python tooling. And so those are the two groups that typically use it. We've had a lot of universities use it for teaching as well. And I'm going to go into a quick demo to kind of motivate you into some of the things we give you. So this is a live instance of Nabari. I'm going to just start Jupyter Hub and Jupyter Lab. And then, you've got different instance types. You've got your, let me make this a bit bigger, actually. We've got GPU instances, A100s. I'm just going to spin up a small instance right now, just because some of the larger instances take a few minutes. This is going to start up a Jupyter server on this instance type. And in a few seconds, I should get my Jupyter. Okay, and so this lands me into kind of the Jupyter window we're all sort of familiar with. And let me go back here. And we just do some niceties. We integrate various plugins like Jupyter AI and Dask and other things that will make life easier for people. We implement shared folders that based on which access groups you're in, you'll have access to, like, I'm in the analyst group, so I have access to an analyst shared folder. Then we do we can start notebooks, we can start a terminal, we can start a code server instance, we can download examples, and these are all the different software environments I have in the system. And that actually becomes a large part of this, because most people, when they set up a Jupyter Hub system, deploying a new software environment involves creating a new container, pushing it to a registry, and then adding it to the system. What we've done is we've built a environment management solution, which lets you have your own personal environments. And I have an environment for AI work, and these environments also are versioned. Like if I look down here, if I look at this environment, this one has versions which I can go back and forward on. And up here are my personal environments, which I can access. But down here, you can have environments that are controlled by someone else. Like, so if you're a department lead, maybe you can create an environment and share it with your group, but people using the environment won't be able to change it. And if I want to create a new environment, I just click new, gives me an interface to add packages. And when I do create packages, it automatically stores all the artifacts, a Docker image, downloadable archive, a log file. So it forces reproducibility and best practices behind the scenes, even though you're not thinking about it as an end user. Then some other things which are nice, if we have a notebook, let me just pick a notebook. So if I pick some random notebook, like this Dask stress test or something, I can kind of click a create job, and I can either run it now or on a schedule, and then hit create. It'll create a job, schedule it on Argo workflows, and give me the results back to my folder. So a lot of little conveniences that a data scientist would actually use, and then a lot of collaboration tools integrated as well. So if I go back to the main window, these are dashboards that my colleague has shared with me. So if I click on this, my colleague Pavitra has shared this climatology dashboard with me. And so you can make a dashboard with Streamlit or Panel or any of the other tools like Plotly or anything. And then you can click Deploy App, and you can kind of give the name, select which framework you're using, like Bokeh, Streamlit, stuff like that. Add environment variables, decide who you want to give access to, whether you want to give access to a group or an individual person, whether it should be available for people in the public or private to your organization. And once you do all that, you can share it as this. So that's a really quick demo. There's lots of other features in Nabari that I'm not going to go into right now. But I'm going to, hopefully that's kind of showing you why you might want to use this. But with that, I'm going to kind of keep going. Now you've seen that, how do you actually get it installed? This is a high-level architecture diagram showing you all the stuff that needs to be deployed on Azure to get it working. I'm not going to go into this. There's auto-scaling, there's, all the different tools. But at a high level, Nabari has this idea of a DevOps or non-DevOps approach. So this is kind of the same idea I talked about Star Cluster. Hopefully, if we've done our job, you should be able to grab your Azure credentials and not really know anything much more about the cloud and deploy this and maintain this, okay? And so we start off with a YAML configuration file. We use that to create some Terraform stages. We kind of plug along, and then it deploys your platform. At a high level, we have these commands in the system. We have a Nabari init that will create your basic YAML file. And then we do a Nabari deploy that takes that YAML, validates it, renders it into Terraform deployment scripts, and then pushes everything to Azure. Now, going through some of the details, we're first going to set up the service principal, and so we'll create an app, and then we'll create a secret for the app, and then we'll grant that service principal permissions to manage resources on your Azure subscription. This is what you'll do in Azure, and then locally you'll install Nabari on your laptop. You do pip install, conda install, prefix, a pixie install, whatever you need. Just install it's a pure Python package, and it'll install. Then little bit of local setup, you just make a folder, and then we usually tell people to run the guided init, and this is a small wizard that runs on the command line that asks you a bunch of questions. And essentially, we'll run the guided init. It'll ask you whether, where you're deploying. It'll ask for some of the secrets and environment variables, which zone you want to deploy in, what the project name is, a few other questions. And then at the end of that, it's going to spit out a config file. And this config file is based on some default instance sizes and things that we've built and you might want to go in and modify which instance sizes, what the min-max node numbers are for each node group and things like that. There's also some extra work if you're including GPU nodes or other things. We can also, in the guided init, it'll ask you whether you want certain services deployed. Do you want MLflow deployed or not? Or do you want, so you can kind of pick and choose what you want. Eventually, you'll end up with a configuration file. And then it's actually, that's it. You hit Nabari deploy with that configuration file, and you wait 30 minutes, and you see lots of messages stream past. And with that, you should have a fully functional data science platform, which your organization can use in the cloud. And we usually put the config in GitHub or GitLab, and then the way we maintain the system is we just do pull requests on that Git repo, and then when you do the pull request on the Git repo, it automatically redeploys via Terraform using either GitHub Actions or if you're using GitLab runners. So the whole point of it is it's not about just you've got a defined configuration that you can easily deploy with one command, and then maintaining that is maintaining one YAML file. And so we're trying to reduce both the initial deployment cost and the long-term maintenance cost of the platform by making it as simple as we can. And hopefully you shouldn't need to know anything about Kubernetes. So some specific things we had to do for Azure. Again, so essentially we can deploy on any Kubernetes, but for Azure, some specific things we had to do is we hit, each cloud has its issues, and we hit a couple of things. One is storage account names have to be globally unique. And people typically, when they deploy the platform, they call the project Nabari, and then that conflicts with other things which are called Nabari because of this globally unique thing. So we actually just add a little random postfix to the names to avoid that conflict. The other thing which was very useful is we actually use Azure Workflow Identity to relate the Kubernetes service accounts to the managed identity. And this lets us inject credentials easily. So something like for example, MLflow needs to know how to access blob storage. And so this gives us a way to do that. So those are couple of things. Over time, we've got lots of bug fixes and security things and everything else that we've worked into the code base for Azure specifically. And that's one of the reasons we keep testing weekly, because we keep finding these things, get the security scans, fix the Docker images, all that kind of stuff. You can try this yourself. If you go to the website, we have a how-to for Azure, and you should be able to, hopefully just copy your credentials, sign up for Azure, follow the steps here, and you should be able to deploy in a body. And if you can't, let us know in GitHub, and we'll fix the documentation, because the point is you shouldn't be a cloud developer to be able to deploy this.